Everyone, welcome to my channel. So here today we are going to be dealing with binomial expansion, dealing with fractions and negative powers. So these do not have an end, they run until infinite. So when we are expanding, maybe we could just expand to 4 terms, then say plus dots to show that it is continuing. So now one of the things that we need to know about these are, firstly, how we expand. Now let's get some basic information. So if you have 1 plus x to the power of n, we are going to have the form which we are going to say 1 plus, so this 1 plus the nx plus the n open brackets. I'm going to explain where these things are coming from, n minus 1 like that. Then we have over the 2 factorial times our x squared. Then we have our plus our n open brackets n minus 1, n minus 2. Then we have over our 3 factorial x to the power 3 plus we are going to say dots. So now where is this coming from? So this n, where this n is coming from, so remember from the binomial expansion, when you say n combination 0, this will give you 1. So that's why here we have n combination 0. That's why it's not showing, but we just get this one because this one change anything. Then if you have n combination 1, n combination 1 is equal to n, like that. So that is how come we have this n. Then if you remember, this first one will be having the power, then this one will be increasing. So here it was there, it was just that x was to the power 0. Here x is to the power and it's continuing to increase, x to the power 2, like that. So I've explained how this is coming about, x to the power 3. Now 1 is not showing because 1 won't change anything. So now we have the nx, that's how come we have the nx. Now if we look at this one, n open brackets n minus 1 over 2 factorial, where is this coming from? So if you have this one is n combination 2, so this is n combination 2. So how did they come up with that? So let's say we have our n value is 3, then we have combination of 2. So this is the same as 3 factorial over our 3 minus 2 factorial, then the 2 factorial, like that. So now what this means is that we are going to get something like this. So remember, 3 factorial is equal to 3 times 2 times 1. Now what does that mean? So this means that even if someone was to write 3 times 2 factorial, it is still the same because 2 factorial represents 2 times 1. That means to say we haven't excluded anything. Now with that said, it means that what is this 2? So this 2 is, we have a 3 times open brackets 3 minus 1. 3 minus 1 factorial. Why? 3 minus 1 is equal to 2, which will still be 2 there. So getting that idea, we are going to say that we are going to have 3 open brackets 3 minus 1 factorial over our 3 minus our 2. So in this case, since we have the 2, we can also say 3 minus 2 factorial. What is this? 3 minus 1, that's 2, times. So we have 3 outside times 2. 3 minus 1, that's 1. So I haven't changed anything. So we have minus 2, then we have the factorial times the 2 factorial, like that. So this one and this one will cancel each other so that we can have, what are we having now? We have a 3 open brackets 3 minus 1 over the 2 factorial. Now what is this? Now this 3, it was 3 combination of 2, if you recall. Now what if 3 changes to a value such as n? So this n will replace, there we have our n open brackets n minus 1, n we have put it there, over the 2 factorial, which was the general form, which was our 1 plus our nx plus our n open brackets n minus 1 over the 2 factorial, like that. For the next term, we have our 4 combination 3. So this should be equal to, we are going to say our 4 like that, factorial, over the 4 minus 3 factorial, 3 factorial like that. So this is going to give us, our 4 is the same as, so remember, we have the 4 factorial is equal to 4 times 3 times 2 times 1, like that. Now what is this? This 4 is 4 times, where there is 3, we are going to put 4 minus 1. 4 minus 1, that's 3. Then 2 is 4 minus 2, that's 2. Then we have 4 minus 3, like that. Then factorial if they are continuing, like that. So that is how we are going to do it. So you can agree with me that even if I was to say 1 factorial, it is still 1 time, just 1. So that is how come we have that. So with this said, we are going to say something like this. So it will be a 4 open brackets. We are going to have our 4 minus 3 like that. Not minus 3, sorry. Let's begin with 1. Then we have our 4 minus 2. Then we have our 4 minus 3 like that. Then we are going to say factorial over our 4 minus 3 factorial like that. Then 3 factorial like that. Then the value it's going to give us is a value that is equivalent to, we are going to have our 4 open brackets, 4 minus 1, 4 minus 1, 4 minus 2. Then we have 4. As you can see, this and this cancels. So we are going to remain with over our 3 factorial like that. Now remember, this was a 4 combination 3. Now let's say 4 is replaced by n. So we have n combination 3. It will be equal to, where you see 4, you are going to put n minus 1, n minus 2 over the 3 factorial like that. So this is how we do it. So in all cases, this is how we are going to be answering. So the general form, 1 plus x, I was just showing you how it comes about, should be equal to 1 plus nx plus n minus 1, then x squared over the 2 factorial. Then we have plus our n open brackets, n minus 1, n minus 2, then we have over our 3 factorial plus. It's going to continue like that. So that is, so when you're told to expand, you can just expand up to 4 terms, then say plus, continue like that, because it's continuing. So with that said, let's expand some problems. Let's begin with this simple one. So let's say we are told to expand and determine the validity. So we are going to have something like this. We have 1 minus our x to the power of 1 over 3 like that. So to expand this, we are going to say, knowing that, use this 1 plus x to the power of n should be equal to 1 plus our nx plus our n open brackets n minus 1. Then we have our x squared over our 2 factorial. Then we have plus our n open brackets n minus 1. Then we have n minus 2 like that over our 3 factorial times our x to the power of 3 like that. Then we can continue plus dot 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 like that. So just not to say due to space, but just not to say it's continuing plus dot 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 dot, you can put it there. So using this, then we are going to say n is equal to 1 over 3. So the power here, n is equal to 1 over 3. Then in this case, this x is equal to negative x. Then just replace. Using that expansion, we are going to have something like 1. Where there is n, you are going to put 1 over 3 like that. Then we have, where there is x here, you are going to put negative x like that. Then you have plus 1 over 3 like that. Then where there is n, you are going to say your another n here. We have 1 over 3. minus 1 like that. Then we have over our 2 factorial is equal to 2 like that. Then we have plus our n is 1 over 3. Then our n minus 1. So we are going to put 1 over 3 minus 1. Then here we have our n minus 2. 1 over 3 minus 2 like that. Then we have our, I haven't put my x here, so I was supposed to put, so we have squared. Then we are going to have x to the power negative x to the power of 3. Then with that said, we are now going to expand. So we have 1/3 by negative x, it will be negative 1 over 3 x like that. Then we have plus our 1/3. Then we are going to subtract 1 over 3 minus 1. It will be equal to 3 is the common denominator. 3 divided by 3, that's 1 times 1, that's 1, minus 3 divided by 1 is 3 times 1, that will be negative 3. 1 minus 3 will be negative 2 over the 3 there. So we are going to write that here we have negative 2 over 3. Then we have negative x squared. It will be positive x squared if it is in brackets. Then here we have our over our 2. Then we are here. We are going to do the same. We are going to have plus our 1/3. 1/3 minus 1, it will be negative 2 over 3 like that. Then 1/3 minus 2, this will give us 1 over 3 minus 2, it will give us 3 is the common denominator. 3 divided by 3, that's 1 times 1, that's 1, minus 3 divided by 1, that's 3 times 2, it will be 6, which will give us negative 5 over 3. So we are going to write our negative 5 over 3, negative 5 over 3. Then we have our negative times negative x to the power 3. It will be negative x to the power 3. Now we just need to be careful. We are not subtracting, we are multiplying. So let me just say times negative like that. So these are our terms. With these terms, we are going to have something like 1 minus 1 over 3 x. Then we multiply 1 times negative 2, it will be negative 2 over 3 times 3, it will be 9 like that. Then this 2, it will go like that. So all you have to do is just multiply it by saying 1 over 2 like that. So that's how we multiply. Then you write your 2x squared like that. Then you have plus 1 times negative 2 times 5, it will be positive 10 over, we have 3 times 3 times 3, it will be 27. Now remember, why do I forget this? Over 3 factorial. So here you are supposed to put 3 factorial. Here you are supposed to put 3 factorial. So we have over 3 times 3 times 3, it will give us 9 like that. Times the, it will give us 27. So we are going to have our 27, then 3 factorial. So we are going to say 1 over whatever number is here. 3 factorial is equal to 6 without wasting time. Then we have times our negative x to the power of 3. So when we expand, we are going to end up with the value of, we have 1 minus 1 over 3 x. Then these 2 and these 2 cancel. We are remaining with negative 1. Negative 1 by 1, it will be negative 1 over 9. Then we have our x squared like that. Then we have minus, we reduce a bit, 6 divided by 2, that's 3. Then we have 5. 10 divided by 2, that's 5, like that. So we have minus 5. So where's the minus coming from? Negative times positive, it's minus 5 over 27 times 3, that will be equal to 81. 81, we have x to the power of 3 plus dots, dots, dots. So you can expand this to an infinite value. It continues to go like that. So unless you are told to expand 1, 2, 3, 4, 5 terms, you can continue with the 5 terms. So 5 terms, maybe the only challenge would be where the next term would be n minus 1, n minus 2, n minus 3, like that, over the 4 factorial. So you can see the pattern of how things are moving. N minus 1 is with 2. N minus 2 as the last number is with 3. So the next one will be n minus 1, n minus 2, n minus 3, then over 4, like that. So mostly if you are told to expand, just end there and say plus dots, 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 dots. So these dots are important to show that it is continuing. So this is how you expand your 1 plus your minus your x to the power 1 over 3. So the answer is this. Now validity. So to show the validity of the interval is you just get this value together with its sign and say, put it in modulus and say it should be less than 1, like that. So we know that's the absolute value. So you can split this. So this is negative 1. You can split the negative 1 in an absolute value and the positive x in the absolute value less than 1. The absolute value of negative 1 is positive 1 times the x, then you have this. So the absolute value of x will be 1. So if you are told to find the interval, that is the answer. Or if you are told to find the validity, that is the answer. Let's look at another one. So remember, this only works if you have 1 plus whatever. X could be anything. X could be 1 plus 2x, but here you just have to have 1. So now let's see how it works when you do not have a 1 there. So what are you supposed to do? So let's do this one. So if you have your square root of your 4 plus the x, like that. So how do you expand this one? So this one is the same as 4 plus you have your x, like that. Then you are going to have the power of half, because the square root is the same as half. Then with that said, you are going to have something like this. Four factorize 4. This will give us a 4. 4 divided by 4, that's 1, plus, then this 4 will divide x to have this. Now why do we do this? When you multiply 4 times 1, that's 4. 4 plus 4 times the x over 4, that will cancel and still give you 4 plus x, but still maintain the square root, like that. So that is factorizing in short. Then we are going to have half. Now if you are multiplying two numbers, if you have 4 times 3, like that, then you have half. That means to say this half will be here, 4 to the power half times 3 half, like that. So that's how it works. So same here. Now here we are going to attach this half to the 4 and half to the other part, like that. So knowing that we are going to have the square root of 4 to the power half is 2. So the square root of 4 is 2. Then we are going to have our 1 plus our x over 4 to the power of half, like that. With that said, we are now going to expand. So how do you expand this one? So expanding this one is very, very easy in the aspects that you can now use as long as you have 1. So you are going to multiply this at the end. So you are going to say by, so this is how you represent your work, by x plus 1 plus x to the power n, you are going to say 1. Now for me, space. So this should be equal to, but you can write your equal to right there. So you have your 1 plus your nx plus your n minus 1, n minus 1 over 2 factorial plus x squared plus n minus 1, n minus 2 over 3 factorial x to the power of 3, like that. Then you continue plus dots like that. So using this, now for me space, but you can add plus dots. It's very important. So you have, in this case, your x here is equal to that. So you are going to say x is equal to x over the 4, like that. Then your n is equal to half in this expansion. So you are now going to just replace. Therefore, the meaning of your 1, so you have a 2 there. So whatever you are going to get, you are going to multiply by the 2 that is outside. If you want, you can now say this should be equal to 2. Then we have our value, which is, we have 1 plus, where you see n, you will put half. Half is equal to n in this case, half. Then where you see x, you are going to put x over 4, because they are equivalent, x over 4, like that. So we are using this expansion. We are here, n is half, so we have half, open brackets, n minus 1, it is half minus 1, like that. Then we have our over our 2 factorial. Then where you see x, you are going to put x over 4 squared, like that. Then we have plus, so due to space, I'll say plus my n, which is half, open brackets, half minus 1, half minus 2. Then you have, where there is x, you are going to put your x over 4 to the power of 3, like that, over, do we have anything, over our 3 factorial, like that. So with that done, we are going to continue by saying it's a 2, 1 plus, we have our half, not half, half by x over 4, that will give us a value of, I can move this a bit so that we can see. So I've just saved space for this one. I've put it at the end so that it's very much easier to follow. So we are going to have our equal to 2, then we have our 1 plus 1 times x, it will be 1 over 8x. If you want, you can say x over 8, it's still the same. So we have plus half minus 1, so half minus 1, this will give you common denominator 2 divided by 2, that's 1, times 1, that's 1, minus 2 divided by 1, that's 2, times 1, that's a negative 2, which will give us negative half. So we are going to put a negative half here. Then from there, x squared, that will be our x squared, over 4 squared, that will be our 16, like that. Then we are going to have plus, we have our half minus 1, we have found it to be negative half. Then we have half minus 2, so remember we are here, half minus 2, this will give us a value of, half minus 2 will give us 2 common denominator, 2 divided by 2, that's 1 times 1, that's 1, 2 divided by 1, that's 2 times 2, that will be in negative 4. So when we subtract, we are going to have negative 3 over 2. So we are going to have our negative 3 over 2 then we have our x to the power of 3 over 4 to the power 3. That will be equal to a value of 4 times 4 times 4. That will give us a 64 like that. So with that done, let's do that. We are going to now simplify things. We have our 2, 1 plus 1 over 8 x half by this value, half negative by positive, it will be negative 1. Then we are going to say x squared over 2 times 2 is 4 times 16 will give us a 64 like that. So this is what we have. So this times this negative 1, 2, this is a 2. 2 times 2, that's 4 times 16, that's 64. Then we have minus 1 times negative 1, that's negative 1 times 3, that's a positive 3. So we are going to have a positive 3 here over, due to the screen, that's why I'm making some mistakes. So here we have 3 factorial. So we are supposed to put that thing there. So we have the negative positive 3 there. So here we are going to have 2 times 2 times 2, that's 8, times this 3 will be 1 over 3 factorial is equal to 6 times we have our x to the power 3 over our 64 like that. So this is how you solve. From here, what you can now do is simplify where necessary. So we are going to have something like this. So we are going to get something like 2. Then we have 1 plus 1 over 8 like that. Minus, we have our value here. So these values are very important. We were supposed to put 2 factorial here. So that we have, due to the space, it's making me make some mistakes. So here we are supposed to put 1 over the 2. So don't forget the factorial. So we have the 1 over 2 factorial. So this is going to give us minus 1 over 2 times 64 is 128 like that. Then we have x squared. 3 times 1, it will be plus our 3 over, we have 8. Okay, we can reduce a bit here so that we have this 3 can enter into 6 2 times. Here we are going to have 1. So 1 times 1, it will be equal to, we have 1 x to the power 3. If you want, you can just put x to the power 3 over, we have our 8 times 2 times 64. So we are doing this because we know that there will be need, there will be need for us to multiply. So we can avoid multiplying certain values because they can cancel each other. So we have the x there. We are going to say 2 times 1, it will be 2. 2 times 1 over 8, it will be equal to 1 plus our 1 over our 4x like that. So this 2 is multiplying everything. So we have our 2 times 1 over 28, it will be negative 1 over 2 times 1 over 28, it's 2 times 1 over 128. It will cancel. We are going to remain with 64. So we are going to say 64 like that. Then we have our x squared like that. Then we have this 2 cancels with the this 2. Then we are going to have 8 times 64. 8 times 64 will give us 4 times 8, it will give us 32. So it will be 32. So 2 remainder 3. 8 times 6, it will be 48. 48 plus 3, that's 51. So we are going to have 512. So we are going to say plus our 1 over 1x to the power 3 over our 512. Then we are going to say plus dots, dots, dots. It's going to continue like that. So that is the expansion for that problem. Let's try another one. Before we try another one, let's look at the validity of this one. So for the validity, you just get this. So validity, the validity will be putting this in modulus, say less than 1, like that. So when you do that, what we are going to have is that this can be split. This is the same as 1 over 4x, like that, less than 1. Put this in different modulus bars. We have 1 over 4. Then we have another one which will be the absolute of x. So as long as you do this, it's still the same, less than 1. The absolute value of any number is positive, so it is just the same, absolute of x, like that, less than 1. From here, just cross multiply or just multiply by 4, whichever you are comfortable with. So this and this cancels. So but you multiplied 4 because it is 1 over 4. So on both sides, it will be the absolute value is less than positive 4, like that. So this is our validity for that one. Let's look at another question. If we have this one, let it go up so that we have our 2 plus our 3x to the power of negative 2, like that. So by doing that, we are going to end up with, let this 2 divide everything. So when it goes up, this becomes negative. So let this 2 divide everything. So we are going to have our 2, open brackets, 1 plus 3 over 2x. Then we have to the power of our negative 2. In such a way that if I multiply this by this, it will give me this. This by this, it will give me that. So with that said, we can now expand. First, let's distribute this negative 2. It will be 2 to the power negative 2. Then we have our 1 plus 3 over 2x to the power of negative 2, like that. So this is the same as 1 over 2 to the power 2. So that's the meaning. Then we have 1 plus our 3 over 2x, like that, to the power of negative 2. So what we are going to have is, we are going to expand this. So we have 1 over 4. 1 plus our 3 over our 2x, like that. So it's negative, meaning to say it's not ending. So we are going to have so to the power negative 2 using, so we can say by 1 plus x to the power of n. Don't forget this. It will be 1 plus nx plus our n minus 1 x squared over the 2 factorial. Then we have plus our n minus 1, n minus 2. Then we have our x to the power of 3 over our 3 factorial, like that. Then we have plus dots, dots, dots. Like that. So in this case, we can see that this is your 1, then your x is equal to this. So you can say n is equal to negative 2, x is equal to, we are going to have 3 over 2x, like that, then replace. So we have 1 plus our n value. Our n value in this case is equal to negative 2, so minus 2. Where there is x, we are going to put our 3 over 2. Is there a positive or negative? Okay, positive. 3 over 2, we have our x, like that. Then we have plus, what's our n value? So we say minus 2 minus 1 over the 2 factorial is just 2, like that. Then where there is x, we are going to have our value, which is our 3 over 2x. Then we are going to have the power of 2, like that. We continue to the next term. So we have let's just be careful here. It's okay, but we just need to differentiate it properly. Then the next one, it will be this n, but due to space I'll put it here, plus our n, which is -2. So minus 2, open brackets, we have -2 minus 1, -2 minus 2, according to this, over our 3 factorial, which is equal to 6. Then we have our times our 3 over 2 x to the power of 3. So here we have x to the power 3 plus, it continues, dots, dots, dots. So we are going to have our 1. So remember, all this is being multiplied by an external value of 1 over 4. We are going to include it. So we have our 1 minus, we have our this value times everything there. We are going to get this one cancels, which we are going to get our 3x like that. Then we have the next value, -2 times, so we have -2, -2 minus 1, it will be -3 like that. Then we have over our 2 factorial, which is our 2 there. Then we have 3 squared, that will be times our 9, x to the power 2, over 2 squared, that will be our 4 like that. Then last but not the least, let's work out with this. So we have -2, open brackets, -2 minus 1, that's -3. This -2 minus 2, that will be -4. Then we have over our 6 like that. Then we have times 3 to the power 3, that will be 27, x to the power of 3, x to the power of 3, over, we have 2 to the power 3, that will be equal to 8. Then we are going to add plus dots, 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 dots. So we have 1 minus 3x like that. So this one and this one cancels. So if this one and this one cancels, so we are remaining with a -1 times -3 times our 9x squared. Then we have over our 4 like that. This is going to give us, then here, negative times negative times negative, it will be -2 times 2 times 3 times 4. This will give us, okay, let's avoid doing that. So we can divide this divided by this. We are going to have -1 here. Here we are going to have 2. So we can even divide this one and this one, so that we have -1 times -1 times -4 times 27 x to the power of 3 over, we are just remaining with 8. When we do our calculation, we are going to get 1 minus 3x. Then we have plus 3 times 9, that will be a 27. So you can see negative times negative, it's positive, over our 4. Then we have our x squared. Negative times negative times negative, it will be a negative value. Then we have 4 times 27. This will be equal to a value of 108 over our 8. So we have plus dots, dots, dots. So this was the expansion, but remember, we can say therefore 1 over 4 to the power of 1 over 4 times our 1 plus 3 over 2x to the power of -2. Remember, this is equal to this expansion without this. So we are just going to multiply 1 over 4. It's only that I don't have space. Then you have 1 minus 3x plus 27 over 4, x like that, x squared for that matter. Then you have minus 108 over 8 like that, plus dots, dots, dots like that. So this is going to give us this by this, it will be 1 over 4, minus this by this, it will be -3 over 4. Then we have our x squared, this times this is going to give us a minus Which term have we skipped? Okay, here. This times this, we are going to have positive. So this times this, 27. 4 times our 4, it will be equal to 16. We have x squared there. Half times 1 over 4 times 108 over that, it will be 108 over 4. This will give us a value. We can divide 4 in here. 4 divided by 10 is 2, remainder 2. 28 divided by 4, that is a 7. So it enters 27. So we have 27 over 4. So we can say minus, since there is a minus, 27 over 4. Then we are going to have our x to the power 3 plus dots, 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 like that. So this is the value for that one. So let's see the validity. So remember the equation, when we factorized it, it was 1, open brackets, 1 plus our 3 over 2 x to the power of negative 2. So validity or interval, you get this. We have our 3 over 2. We put it in the modulus and say it should be less than 1. You split this, you are going to have 3, 2 in one modulus and x in one modulus less than 1. This is going to give us 3. The modulus of 3 over 2 is 3 over 2. Modulus of x less than 1, like that. Then you can cross multiply, or you can just multiply by the multiplicative inverse. If this is 3 over 2, you are going to multiply this value on both numbers. Even if you cross multiply, it will still be the same. So the absolute value of x will be less than 2 times 1. It will be a 2 over 3, like that. Let's look at our last one. So using this one is the same as, it goes up, it will be 1 plus 4x to the power of negative 2. So this will be equal to, we have 1 plus x to the power of n, the one we are using, 1 plus nx plus n minus 1 over 2 factorial x squared plus our n minus 1, n minus 2 over 3 factorial. Then we have our x to the power of 3. So this is going to give us our x there. In this case, we are going to say n is equal to negative 2. X is equal to, in this case, it will be 4x, like that. So we are going to have something like this. Our 1, where there is n, we say minus 2. Where there is x, we say 4x, like that. Here we have minus 2 minus 1. Then our x is 4x. Then we square it over, we have 2 factorial, which is a 2. We are going to say plus our n, in this case it's negative 2. Then we have negative 2 minus 1. We are here, negative 2 minus 2 over 3 factorial, which is 6. Then we have times our 4x, x is 4x to the power of 3. So to finally give our final answer there, we are going to have our 1 minus 2 times 8, it will be 8x, like that. Then we have minus our 2, negative 2 minus 3, that will be our negative 3, like that. 4 squared is 16, x squared over our 2, like that. Then we have negative 2. Negative 2 minus 1, it will be negative 3. Negative 2 minus 2, it will be negative 4. Then we have over our 6. 4 to the power 3, it will be equal to 64. Then we have 64 x to the power of 3. So we have 1 minus 8x these 2 cancels. We are going to remain with negative times negative is positive. 3 times 16, that's 48, x to the power 2. Then we have here, we have negative, 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 it will be negative. 2 times 3, that will be 6 times our 4 over our 6 times our 64, x cubed plus dots, dots, dots. Now the reason why I have just multiplied this is I just want this to be similar, so that the final answer will be 1 minus 8x plus 48 x squared minus 64 times 4 will give us a value that is equivalent to 4 times 4 is 16, remember 1, 4 times 6, that will be a 24 plus 1, that will be a 25. So we are going to have a 256 x to the power of 3 plus dots, dots, dots. So this is how we are going to answer that one. So that's that on binomials on that one. So let's just state the validity. So we had a 1 plus our 4x like that to the power of negative 2. So to test validity, so the validity, we are just going to get our 4x like that, put them in the modulus bars and say should be less than 1. Then we are going to have separate the 2 modulus bars. The absolute value of a positive number is itself, x like that, less than 1. So this is going to give us over 4, which will be a value that it will be equivalent to the absolute of x is less than 1 over 4. So that is how we solve that one. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.